Hi, everyone. Good morning. Can you hear me?
Yes, sir.
Uh, I think we should start. Since it's 28, that's fine for us. Still okay. Today is actually we start finally we start our lesson, and of course we will be cover those kind of content. For example, what's the complexity algorithm, which is very core in this course, because everything you trying to measure each algorithm, we trying to use the perspective to try to use this criteria, which is that the complexity always measured by time complexity and the space complexity. That's the reason we will be explain much more about that, because this is whole semester we say that algorithm time complexity is login, that algorithm time complexity linear time, quadratic time. What does means, right? So that's kind of the language that we're trying to represent it, which is the simple way, in mathematical way. It's much more direct. After that, we will be give a prime factorization, that using the prime factorization case, that what does means actually complex the algorithm. Of course, anyway, we can take any algorithm, but we can just take this example that trying to expose the details of the complexity algorithm. After that, of course, we beginning to introduce many stake, Q, DQ. Those are actually stake and DQ, very special list, special collection, let's say, that we can use this collection to it's actually it's a linear data structure, but it's a kind of extension. You can develop from the array list, but I think there should be, before that we also talk about a little bit more array list, because all of them is so far we start learning the PP1 and PP2. I think you're very familiar with the array list. Probably you already beginning to use the stake and the queue, but doesn't matter. But the stake and queue kind of special type of array list. You can say that. So that's the reason we will be talk about more. Then we also talk about from the perspective, of course, always perspective, that the complexity, algorithm complexity. So yeah, so let's dive into that. Okay. So so any question?
No.
No, sir.
Yeah, I can continue to do it in my way, but it's better to sometimes interact. If you any question, or it would be good. We can change a little bit. Not linear forward representation. Anyway, we can stop somewhere else, then we can deeply come back. Then after that, it's also fine. By the way, I think most of them you already start learning. I think you, whatever the level, maybe you don't have time, but nevertheless, you already start this, algorithm before, teach the algorithm before. Let me ask you a question. How many person never enrolled this course before? That's it, only the first time. Do you any case that in this?
Yes, I am.
Oh, what's that? Why is you choosing? I mean, my curious about that. This for example, each semester has own schedule. Probably most people been retake or been not no time to attend the class, then that's the reason the summer school must get. But Ali Khan, you said it's his first time, right?
All right, it's my first time because I'm from another faculty, School of
Uh-huh.
Applied Mathematics, and I
Okay.
decided to take this course.
All right. So this is very, I mean, this is very important. Such, I want to know if such a student would be better to, more active, because probably you didn't hear about some concept. So I can able to stop here, then we can talk about more. So that would be good if you let me know. Okay. It's fine. So let me go back to a time. As I said, the algorithm and data structure, the courses trying to measure the application um, with a very efficient. What does means is with a time from the time complexity, whether it's very fast or whether it's efficient to the memory and the computer. So basically, what we're talking about the algorithm actually, which is based on binary architecture of the application. What does means is, of course, uh, nowadays, every notebook, computer, PC, all is based on the binary architecture. Of course, there is a quantum computer beginning to use that some different area. There's already have a prototype, so it's totally different, computer architecture. But we talking about only the binary architecture. That's the reason we all the time two based of some login. I mean, two based of something. That's the reason why is the two power of we trying to measure any primitive type. For example, what does means primitive type? Do you in the computer programming language? Primitive type. Can you tell me, guys? Can you give me example? Be active. For example, integer, right? Float, decimal number, char, boolean, those are primitive type, right? Everything in trying to represent in the information in the computer using those primitive type to organize, I would say, the information. So those are actually the based on the binary architecture. So that's the reason if I'm trying to understand the integer, of course, if integer is long, then it's 2 power of 32, right? Or long is 2 power of 64. I mean, if assigned, it is also another type. But this is content of the PP1 and the PP2. So it is actually the prerequisite for PP1 and PP2. So if you didn't understand what's primitive type, then you should ask me. Then I can deep dive, explain to you a little bit more, or maybe I can give a different resource as well. So so we trying to. I'm come back to topic. So we trying to understand what's the complex the algorithm actually binary based binary hardware based architecture. I mean application we are going to measure. So it's kind of we two things, right? Two things we needed to measure. I trying to edit two things. Okay, let me just edit another slide. I think it's necessary from that moment. Okay, so I think the app ideas, algorithm, data structure, measurement. I mean, app structure, measure. Okay, the complex. Let's say simply complexity is actually two perspectives. It's time, time complexity, and the space space. But both are those applications actually based on binary architecture of hardware. Okay. I mean, what does hardware? We can say PC. Yeah, always those are what does means I'm trying to say. So, time and space complexity, right? All right. So time complexity means how much the application will be spent in order to run this in the particular application, particular function, let's say. So they will be represented how much fast, right? How much fast. So usually we'll be saying how much fast. That's we trying to understand. What's the space is how much app. It means applicate how much the app will be spend the memory in the PC, in the whatever, in the operating system, in the memory, in the PC, let's say. Okay, that's they trying to understand. So we trying in this course let you trying to understand how can I how can I improve the application of performance, or whether I can make this more faster, whether I can save more space in order to get some advantage. Yeah, that's we trying to learn in the very general level of the understanding the application of the data structure algorithm. So we're trying to understand the space and time complexity. Okay, that's too simple, but it is still too general, too abstract for normal person. So usually we will be, it's very straightforward to represent in the math way, which is being called big O concept. Okay, so big O concept. So let's talk about what's the big O concept in mathematical way. Okay, because usually mathematics is more straightforward, most direct way, more simple way, we'd say, more short way to represent everything. Okay, so that would be good. So what's the big O concept is, usually we talk about those are very frequently used. For example, it's being called O1, sometimes being called order 1. This is a ON. Sometimes we call it linear time. It's the same things. Okay, it's a general representation. This is a mathematical way to representation, and I would say, that would be like this. Let me. How can I? That would be 2 power. Do anything I can? At this means 2 power of n. That I'm trying to say. So n square time. It is n square time is quadratic time, or sometimes being called the quadratic time, right? So this is mathematical way. This is a general representation, and then also O login, right? So usually we're talking about O login is it's not 10 based, it's 2 based. Okay, we'd say 2 log. Actually, they trying to say 2 power of login. That's they trying to meaning of what does means login. Okay, that's you should know, because we are, as I said, this is kind of binary architecture, right? The other one It's very frequently used, and login. So it means it's very frequently 1, 2, 3, 4, 5. This one is very frequently used. So that's the reason we need to understand. So what does means? Okay, what does means? Okay, big O notation. So it's amount of effect of algorithm required complexity of task used to estimate worst case runtime for algorithm, how hard an algorithm may have to work and solve the problem. So that's a general description, but nevertheless, when we talk about the Spiegel concept, we usually talk about 3 case. It is it's been called worst case, worst case, um, bad case, and in the middle case. It is a kind of in between, right? Okay, so they will be talk about always they existed the 3 different kind of case. Okay, just middle case. Okay, so right, so what's the worst cases? Actually, worst cases which is the bad performance at maximum. It would be so, but this should be worst case, and bad case is usually very rare. I mean, usually it's a not general case. I mean, 90% is in the middle case. 90% is normal case, but bad case and worst case to extreme case. So which is that very rare, but they existed in this application life cycle. So that's we trying to oh, sorry, I'm wrong. That's best case. Best case and bad case, or bad case or worst case. Okay, I would say bad case not fine, or worst case also fine. So it should be two extreme, bad and worse. And in the middle, it's kind of most time it's a normal process. So we trying to represent two case. Say, okay, bad case or bad case is quadratic time, but best case is fixed time, or that's we trying to say. Okay, in other it means another representation is fixed time. Okay, sometimes being called fixed time. Okay, what does means fixed time? It means whatever you data structure increasing the size, whatever you data structure the consume the data, whatever 1 terabyte or 1 megabyte, doesn't matter. It's a bigger or smaller. They running the certain operation. They always spend fixed time. That's sometimes other one or one. That's the meaning of the mathematical representation. What's the linear time? It means depend on the size of the data structure, which is, for example, increasing from small to bigger. For example, start from the 10 megabyte to 1 terabyte. Keep increasing. Based on the size, they will be also, performance also will be increased, or some operation will be spent, certain, performance. They will be consumed certain performance. So it should be dependent on the size, or the time would be linear. So that's the reason linear time complexity. It's being called, or linear. The cases example is linear search. That's the example. Okay, real life example. Examples. Okay. That's also real-time examples. In array, look up the index, it's a fixed time. Why? Because they will be indexed. as long as they index, they will be no, they will be directly access the memory address. So that's the reason. I can directly access the 1 or 100 index. There is no need to, there is always the fixed time. By the way, it's a fixed time doesn't means one time. Okay, fixed time maybe 1 millisecond, fixed time maybe 10 millisecond, fixed time maybe is 1 hour. Okay, but it's not dependent on the size of the structure. Okay, that doesn't matter how much you change the size, so they will be doesn't change the operation of the of the complexity, I mean, over the time. So that's the reason fixed time. You should understand. So quadratic time, okay, quadratic time is let me start from the first one, okay. So big O notation, first case algorithm simply test whether the first element have a vector is equal to the second element of the vector, and the 10 element it's one comparison, 100 element also one comparison. So let's say in that I mean let me algorithm simply test whether the first element of vector is equal to second element of the vector. That's a kind of comparison operation, right? So what does means vector? By the way, do you know what's vector? It's a kind of concept from the PP1 or PP2. PP1 actually. Guys, are you asleep? Are you here? So vector is actually the dynamic array, right? It's a dynamic array, and so it doesn't matter that it means array. So you can, if you didn't understand what's vector in this dynamic array, it's no difference in between. In general, there is a same feature, but the vector is dynamic array. It means they will be size can be resizable. It's a dynamic, but usually we will be use array. We will be give them fixed time, right? So it's being called, if you fix time, we call it array. But if this dynamic array, it's kind of based on it's being called vector. Okay, it doesn't matter. So it means I'm going to compare the and in neighbor of two element always just one comparison. So that's one case. Constant runtime, which is the represent big O notation or one. Okay, so we understand what that means, right? So it's big O. Second case is an algorithm that tests whether the first element of the vector equal to any of the other element of the vector required at most in one comparison. So that's kind of now any element trying to compare it. So you trying to any position. So it means you have to go through from at the beginning of the position to end of the position. If the size of the element vector is n, so in order to compare the each of the element, you will be spend n minus times of the comparison. So that's the reason you're trying to compare all of the element. Of course, they will be spend a linear time. I mean, the size of the element minus one times we will be spent for this operation. Okay, so it means 10 element we have to compare 9 times, 100 element we have to compare to 99 times. So that's being called linear representation, or in mathematical we call it ON, or sometimes we call it linear runtime. The algorithm operation, it's linear runtime. Okay, so it should be understandable. Third case is, let me introduce first an algorithm that tests whether any element of the vector is duplicate elsewhere in the vector. Okay, so it means in this element, in the how to say, in the linear position, linear sequence, there is not one times, maybe several times. So that's the reason big O notations highlight. So they will be, develop the size possibly to extend. So so certain operation will be used, such kind of complexity. So for example, in the bad case is that, for example, it is a kind of 2 by 2 matrix. The n element possibly to n to n possibility. So that's the reason, we call it quadratic time. So usually the bad performance, worst case, they will be they will be usually we call it in that mathematical way, okay, O n squared, or we call it quadratic run times. And the real-time example, let me say, real-time example, probably in the PP1 you learned bubble sort, right? Bubble sort is each of the element will be compared from beginning to end. So it means first element they will be start from let's say 100 element. So they will be start each element they will be compare 99 times. So second element also 99 times. Not maybe, yeah. Third element is second element 98 times, third element 97 times. So nevertheless, if they trying to find, actually each time is 99 times, because probably if the third element they trying to find what's the second bigger or what's the third biggest element. So they should be start from the beginning to end. They try to find the position. So that's the reason. Actually, they have a would say 100 multiply 100 times. So it means 2 power of would say 100, and the 100 multiply 100 means 10 power of 2, right? Then 10 power of 4, right? So that's kind of complexity they will be spent. For example, a real example, as I said, bubble sort. So it's usually we trying to represent the bad case. So that's very three fundamental representation in the big O concept. But we will be do it a little bit combination in between. Other things that login time, sometimes efficient linear search. I mean, linear search is kind of, that's linear time. Now, I think in order to understand the algorithm, we're trying to give a little bit example. Okay, this is example. Okay, what's the examples of? By the way, there is also exist another cases login times. Did I edit login times? There should be another case. It's been called case 4. Case 4 is log 2 based n times. How to say 2 based n? Maybe you can talk about that. That's usually we'll talk about what does means 2 based n times. Okay, let's say that's login. Example of log based login time. Log in times. Okay. For example, what is a login? It means let's say linear search, right? 100 of the login I mean, 1,000 of login is 20, right? And then 100 of login is in between 7 and 6, right? It's if it is 2 power of 6, 2 power of 6 is 64, right? And the 2 power of 7 is 127. So it means in the 100 is actually in between 6 and 7. But if we talk about the 1,000 login times, 1,000 of login is 20. Okay, so that's the representation in mathematics. You should understand. So it means if it is a 100 operation, they will be login time. It means there's 20 times. And then this is a real example is in the binary search and the 1,000 element. In the 1,000 element, they're trying to find I don't know. It's trying to find one element. They will be at most, in the worst case, they will spend just 20 times. Okay, that's interesting, because if I using the linear search, actually they will be spending 999 times. For example, if I using linear search is 999 times, but if I is using the binary search, it's just using 20 times. Okay, so that's meaning. That's meaning of why we learned algorithm. It's nobody will be stupidly used 99 times if there's existed 20 times of the comparison, right? So, for example, if you let's say each time spend some cost, for example, if you spend $1 each time, so they will in the accomplish a certain operation, they will be spend $99, but this is $20, right? So nobody will be used such a way to accomplish the task. Instead of they will be choose smart way to doing. So that's the reason if you start learning the algorithm, if you start learning the data structure and the algorithm, the course, they tend to let you think differently. If you understand that there is a way to we can improve, so we can try to get this better performance. So actually, that's kind of direct example. Yeah, directly represent if I using this way, I will be save time. It means time is cost, right? And then also merge sort. There is another example, real-time example. We will be explaining in the future what is a sort algorithm and search algorithm, not now, but what I'm trying to explain is there is a bigger concept, okay? So there's a first case is login. And then this login is, it's a little bit efficient in between, better than linear time, okay? Why is linear times, for example, linear time is just how much size of the operation, size of the data structure, they will be spent similar, size of the, n-1 times of, which is that 99 times. If I example of the size of the collection is 100. So it's interesting. And the merge sort example actually much more interesting. It shows that n login times. If you understand login, so you just multiplied n. For example, the operation is n, its n is 1,000, and the login is 20. So it means the merge sort actually the performance is 20,000. So what that means is you should understand if you use the merge sort in order to sort used by merge sort, they will be spent 20,000 times accomplish the sort algorithm, right? So that's a complex merge sort, and the insertion sort is, square time, quadratic time, which is means 1,000 and multiply 1,000 means 1,000,000 time. Okay, so if you choose, you have a many sort algorithm, right? So for example, you have a merge sort, you have a insertion sort. Which one you want to going to use, right? Which one you are going to use? Somebody follow me, right? So from this data, you can able to say without any kind of idea of the what's the merge sort and the insertion sort. Any idea? Which one you want to going to recommend? Hello? That's the question.
In login.
All right, because in login is, so if we only have a two choice, let you say, please use those two algorithm, insertion sort and then merge sort and insertion sort, right? So if you choosing, if you let you choose one of them, you must be choose merge sort, right? Because merge sort is it's 8 times faster than, right? This is 20,000, this is 1 million. So it is a, if you multiply, would say 5 times. If you multiply 5, then equal to insertion sort efficiency. So it is a insertion sort. I mean, they will be spend quadratic time. It means the size of the 10,000, in order to sort the 10,000 element, they will spend million times of comparison. I'm not talking about the time of the measurement, but I'm talking about the comparison times, right? Maybe it's one time spend 1 millisecond, maybe 2 milliseconds, doesn't matter, depend on the hardware, right? If you use a supercomputer, much faster. If you use an original PC, much slower. So fine, but so in this case, good. So merge sort should be better than insertion sort. So you should know. But we will be explaining in the future. Don't worry if you didn't understand merge sort. If you didn't understand insertion sort, doesn't matter. I mean, yeah, a quick sort. There is a bubble sort. You should know. There is a 5-4 algorithm, classical sort algorithm existed. When you talk about sort and the search in between relationship, doesn't matter. You don't necessarily know right now. Now, what you know is you should know, understand the mathematical algorithm, mathematical representation. Say mathematical represent language, big O concept. So we talked about that. Okay, I'm trying to wrap again. Big O, those are, say, linear, quadratic time, login time, and login time. I mean, those are heavily implying the algorithm data structure course. So that's the reason we need to talk about more. So you should understand, you should immediately understand what does means one, what does means fixed time. Okay, that's the same things. If I talk about fixed time or one, it's same. Okay, if I talk about other one, also same meaning. Okay, n, it means linear time. It's very easier to understand. The n square, it means quadratic time. What is quadratic complexity? Which is the example would say that one is quadratic time. That's, yeah, that one. Yeah, that's the quadratic time. 1,000 element, size of 1,000 element. In order to use insertion sort, they will be spent 100, 1,000 multiply 1,000. So its quadratic time will be result is 1 million. Okay, so it is good. You always, you should keep remember the 5 case. Okay, basically actually 4, and then others kind of different kind of combination. For example, this one is kind of combination. Okay, let's continue. So if you understand linear complexity, I mean fixed time complexity, in login time complexity, sometimes we call it quadratic time complexity, you should understand, and how you can, you should understand it is the meaning would be better to understand this course. So let me explain only one example. For example, binary search. Binary search is as I said, there is a much more faster one. For example, the 10,000, it's a search, by the way. It's a search and sort. There has a relationship. We talk about later. But a binary search is, as you can see, it's login time complexity. Login time complexity, it means in using the binary search, it's 1,000 element. I will spend just only 20 times to find if I use binary search. So binary search has one drawback. I would say precondition, not drawback. That's in the binary search actually is the best search algorithm in the binary architecture in the computer in our application, which is login time, right? So, but this precondition, they have to be already been sorted. So that's the reason we needed to learn sort algorithm. Okay. So if I already been sorted, I mean this precondition is binary search have to be been sorted, right? As you can say, they only used to be sorted array. What that means, you have to sort first, then you can able to apply the binary search. Then compare the middle element. I mean that's a specific and precise algorithm itself. How's the binary search algorithm been created? So basically, they say they will be take this sorted array, then they will be cut it in the middle, right? They will be middle element. I mean, using middle element. If equal, then found it. If you're lucky, but not always lucky. It means it's best case. Best case is all right. Best case is fixed time, but it is not. Maybe a million times one times. The lucky one is million one times, but always in general they will be compared from the beginning to end. So the worst case they will be spent login times. So how they will be, I mean, too fast? That's the question, right? Because each time they will be, for example, the 1,000 element. In the second comparison, they will be just left at 50, 100 element. As you can see, they will be fast in the just only one comparison, get advanced at 50% of the, in the previous one advantage. You just need to just kick off 500 element. You just only focused on 500. If it is it means if it is small one, I mean, middle element is smaller than k, they will be just focused on the left side. If I mean middle, let's say left and the right, and in the middle, if the k you're trying to find one element in the left side, it means right side of the 50-100 element, let's say in the 1,000 element, right? So you immediately eliminate the 500 element. If it is the case bigger than middle element, which is that 500, in the middle, 50, 100, this element, then you just need to smaller 50, 100 element, you will be without concerning the your concerning area, right? So that's the reason each time comparison you always get advance of 50% of the performance. So that's the reason each time they will be as third times they will be left to 250 element, and then fourth times they have a in half 175, right? Then just like that, right? So that's the reason binary search too fast. But there's only the one condition: you have to sort first. Okay. All right. So that's the reason. And maybe we can take a rest. Okay. Maybe we can take a rest. then come back in the second hour. Guys, so who's recording? If I just stop here without, okay, then we can.
Excuse me, can you read the message in
Can you repeat your question?
Okay.
What
I
I
can't
can hear.
I can't fill the Google tables with my account because I
Yeah, I
joined
understood.
today.
Okay, understood. By the way, who's recording this lesson?
I
Who
think nobody
recording this
pressed
lesson?
the button.
It's automatically
It
being
doesn't do it
recorded.
automatically. It just that I think we just forgot to press it.
Yeah, I
The
think one it's already been. So what I'm trying to is maybe it's the first part. We don't necessary to unnecessary content being included. So you need to stop it because the second part we will be come back to 10 minutes. We will be recorded again. That should be fine. Nevertheless, okay, this is I'm just concerning it should be useful for you or not. Fine. About your account, if you somebody who's come late, it's that's the reason it's I have to do extra time to actually the admin is not me. I have to request other admin to create your account. So so you needed to send me your request which is included in the just send me in the short message, okay, Ali Khan.
Okay.
Understood, Ali Khan? You needed to, based on the template, there is a Excel. I don't remember the Excel is that one, right? So you needed to give your, for example, a name, student ID, email. I mean, that should be, you should be, then I will be
I
answered
can't
in
edit this document.
this position. You should provide the three information, okay?
I
Send
cannot
me
eb-
personally.
I
Just
cannot
send me
edit this.
personally. I need you to control this. Now you cannot edit. You just send me.
Okay.
If somebody who still needed to account, which is necessary. Okay, let me just. If somebody All right. All right, let's start second part. So that's a real example. That's a real example, which is that how is important the algorithm if we used wisely. For example, it is very, if we use stupidly, it means for 1,000 elements, sometimes the quadratic time means 1 million times. So nobody will be stupidly do the operation 1 million times. Instead of if you want to accomplish it in the 20 times, right? For example, if I sorted the 10,000 element, or not 10,000, let's say 1,000 element, if I use binary search, they will be accomplished in the 20 times. So it should be wisely used, right? It's a smart way. Otherwise, if you use this stupidly, for example, some case, so sort algorithm, real example, right? Sort algorithm is bubble sort even, it is a quadratic time, for example, 10,000 time element, it is quadratic time, it means 1 million times. Merge sort is 20,000 times. If I use an example of 10,000, example of 1,000, and then shell sort is n login times. Quick sort is in login times, but this is it's in general, but this is depend on some worst case existed in the quick sort. For example, worst case, sometimes if you choosing, it's not properly choosing pivot point, there will be consequences quadratic time. So in the quick sort they existed quadratic time complexity, but in the real example, mostly quick sort better than merge sort, and the merge sort is login times, and in average quick sort is also login times, but in the same algorithm, same application using the quick sort faster than merge sort. That's the reason. But you have to avoid worst case in the quick sort. So yeah, right. Keep continuing. That's a search and sort algorithm we speak of value. So as I said, there's a give the many sort and the search of the last. The also comparison. There should be, you should understand that first of all, you should understand in between the relationship in search and sort. As I said, there is a very the most quick sort algorithm is quick search. Search algorithm is binary search. It is login times. Example of that in the 100 element, they will spend at most 20 times. But the most search algorithm, they have to be been sorted data source they will be applied for. So that's the reason we need to learn sort algorithm. And then you can see that there is a many, we have a many sort algorithm, okay? But you can say that insertion sort is quadratic time, selection sort is also quadratic time, merge sort is better, a little bit better, but still they multiply n login times. So that's the reason, the example that 1,000 element is n is 1,000, login is 20, so it is a merge sort will be if we trying to sort 1,000 element, they will be spent 20,000 times. Then also bubble sort is quadratic times, it's 1 million times. And then quick sort is average case, middle, which is I told you, talked about it in here. Actually, the not middle. Mostly we talk about average. Okay, average case. I think it should be very rare to use average case. Right. So it means, as you can see, we needed to find something more efficiently. And in here you can see linear search, linear time, binary search, login time, recursive is linear time, recursive binary search is login time. So as you can see, the search, the most fast one is login times. So, but in the binary search is the most fast algorithm in the not algorithm, say, and the search algorithm, but they have a one condition. The condition is they have to be sorted. So that's the reason we needed to learn sort algorithm. So that's kind of relationship between search and sort. So sort actually, search actually dependent on sort. Okay, so that's a huge important concept you have to understand in between relationships. So as you can see, this is also big picture of all the classical, let's say, most classical sort and the search in this table. Okay, all right. And but this is also important to visualize this idea in your mind. What does means those number? So for example, you have to understand what is the meaning of O login, right? What's the meaning of the ON? What's the meaning of the login? What's the meaning of the N square, right? For example, say, let's say the element is 100. You can represent in the bind, you can represent in the for example, those, if I represent the binary architecture, usually we will be used to 2 power of something, right? 10 is 1000 is 2 power of 10, okay? So that's another way to represent your 1000. So it's kind of 1000 element. If I using the, what's the measurement of, if you say the algorithm is login time complexity, it means O login time complexity, it means this is a result of 10. And the linear time, it means 2 power of 10. 2 power of 10 it means 1000 times. It's the same as the size of the element. If it is an n and login, it means 10 multiply 2 power of the 10. So it means 10,000. O n login, it means 10,000. And then what's the quadratic? It is n squared, it means 2 power of 20. It means 20,000 times. And then this is another way, the example, this is 1 million element. 1 million element spent, I mean, login will be, login is 20. The result of ON is 2 power of 20. It means 20 million. No, 1 million. 2 power of 20 is 1 million. 20 multiply 2 power of 20, it means 20 million. 2 power of 40, 2 power of 40, it means actually, 1 million multiply 1 million. So how much? Which is a little bit bigger size of the element, right? So it means there is a, will be, in the end, they have a it's 6, 12, 0. What is it? 2 power of 20? It means after that one, they have a 12, 0, the element. And the 2 power of 30, it means 1 billion. 1 billion, it's, and after that one, they have a 9, 0, right? 9, 0. So it is a 30. Login is get this. What's interesting that, for example, 1 billion element, if you're using if you remember the binary search, 1 billion element, you're trying to find one inside 1 billion element, find one element at most, they will be spent just 30 times. But if you use the linear search, they will be used the worst case 1 billion times, minus 1 times. So it's very interesting. I mean, 2 power of 30 is 1 billion times, and then this is a 30 billion times. This is I mean 2 power of 60, it means they have a, and after that one, they have a 18 0 in the end. Okay, so such a number you have to able to represent in your mind. So it's very important to understand the meaning of the why we needed to measure the Bigo concept. Okay, any questions so far? No? Okay, then we have a time to explain the second topic, which is that we are going to introduce the several algorithm stake queue, right? So before that, I'm explaining the stake and queue. Actually, you should understand array or vector. There is basically no difference in between the array and the vector. There is a feature same. What's it? It's vectors, dynamic array. So basically, you should understand the array. What's the array is sequential element stored in the collection. But the arrays in the C++, you can represent the pointer. They will be arranged in the memory sequentially. So it means, what does means pointer? It means we just need to understand the pointer itself. We don't need to understand each of the element of the position, because they already been sequentially been positioned in memory. For example, if I know the first element, the memory address, I don't necessarily to know last one, because in the end I can find it one by one. For example, what's the second element? I can add it one position in second. If I try to find tenth element, I just need to move the tenth position, then I can find it. So that's interesting of the array. Okay, but probably you already know, because you already learned in the PP1, PP2. So that's the reason we didn't list it in the data structure algorithm course, but it's necessary, right? If you necessary to know before then to come back to start any data structure first. That's the reason I have to explain to you. Array is sequential data structure. This is pointer. I don't need to only understand one pointer only. So they will be, that's the reason there exists some concept being called index, right? So those operation, I'm start from the, so I think I should added one more slice for, right? Before then starting stake, right? So I think it's necessary. Maybe person who come from different background, right? Array, let's say vector. Vector is dynamic array. What I'm trying to say is you should array. Arrays, one name being called linear data structure. Okay, linear structure. They each element located in memory in sequential order. That's memory. In memory in sequential order. So that's the reason. They have a index, has index. Okay, let's say I can conclusion that this is three sentences. Fine. Linear data structure, each element located in memory sequential order. So if I understand, if I know the one element in the array, for example, they located in the first fourth, fifth, maybe fifth position, then I can find it first element, because I just move the position in the 5 times, they will be find the first element, which is that index of 1, right? Index of 0. Of course, the arrays start from the 0, indexes start from 0, right? So that's the reason the pointer playing the role of the index. The finding element very fast from the algorithm perspectives, fixed time. Find will be fixed time. I mean, let's say you use mathematical way. Insert will be spent. Insert will be spent in login times. No, project times. Insert, update, oh no, update to define, insert, delete. Okay, insert, delete will be spent. Okay, I mean, delete will be spent in in square time. Okay, in square time. How we can represent in mathematical way? How we can do any format that? All right, so that's cool. Format. The text should be like, okay, in square time. That's good. Insert. That's insert, delete is in square project time, right? That's array. Okay, you should understand finding is very fixed time, but insert, delete is finding very quick, but delete, update is very bad. So if you if you're trying to read, if you're trying to frequently insert, delete, we are not going to recommend using the array. That's the reason. Okay. Okay. So you should know. Supposed to be this is kind of you should understand that what's the array. That's the prerequisite. But we trying to explain, come back to stake and the queue. Okay. What's the stake? So as you can see in the Wikipedia, say what's the stake look like that. So if you're trying to get the I mean, in the end of this element, you have to get first in the top. So if you put it in the some element, they will be put it in the end, but you will be get first. That's interesting, right? So it means there is operation very frequent being called LEFO. What means left last in first out. So if I try to put this in the last element, they will be get first. If you trying to access the other one, so it's very important. Last in first out, LEFO, right? So it's being called stake. But as you can see, that's the array. If you trying to access array, they can access any position. They can access last one, they can access first one, they can access in the middle. But this is you cannot access in the middle. You cannot. They have to be take care first. You can you have to get those element previous element first, handle first. You can get up first, then you can get access to element. So that's another one. So stake is actually two operations: push and pop. What's the push? It means you can put this here. What's the pop is you can get it one. So it's very important. There is a very constrained data structure. They have only two operations, but some So that's data structures been limited to other operation. They cannot do other operation, but this one can be used array to special array that they limit to access. Okay, so it means if you put this some element, they cannot actually we needed to explain the linked list, right? Because linked list is it's fundamental of the data structure. Probably linked list we will be explained in the let me just open the syllabus first. Okay, probably you already able to access the syllabus. Okay, as you can see, right, we will be beginning to next lesson we will be beginning to explain the linked list, and then stick and queue actually based on linked list to create the data structure. But this is very interesting. All right, let me go back to topic again. So that's a state. So they have a two operation, pop and push. You cannot do anything. You cannot get, you cannot delete, you cannot remove from any position. You just only start from the end, and also start, push from the end. So it is only the position. There is only the one entry point. You can in and you can out in the only one position. So that's look like. For example, this is example, you put this one and then push this one and push this two, push this three, push this four, push this five. But if you're trying to then pop, if you're doing the pop, it means you will be retrieve 6. If you pop again, you retrieve 5, and pop again, you retrieve the 4, pop again, you retrieve 3, pop again, you retrieve 2. So it means there's only the limit to operation. Okay, that's being called stack. Okay, Lec1. All right. So of course the Lec1, you also let me just explain to stick with other reference. So it means that's a stick, pop and the stick. You need to put this element or you can get out the element. So that's kind of basic representation in the picture, because one picture was 1,000, right? And then here's example. For example, this in the if you're very familiar with the C++, right? So let's say what's that look like? Usually the stack. You can use array. For example, we used the stack operation. We just create this stack, and then in the they already include this kind of let's say library, and then initialize. There's operation top is -1. Okay, at the first is full is maximum size, because the stack is static array, so that's the reason. If it is full, it's maximum size. You cannot put anything else. But the push means they say if it's not full, because this is the size. If it's not full, then you need to the added to 1 initial value is -1. It's added 1. It means 0 links. Then you need to put this in the 0 to element, right? So if it's full, that means you cannot add any element. Okay, that's interesting. And then that's it. All right, that's a push. Support. Push. There's in this example, they just run only the one example, push, right? They didn't give the example of pop, but nevertheless, what's the push means you can put 40, 44, 10, 60, 62, 123, and then 15. So after that, you can able to print out. So it's 40, 44, 20, Yeah, so it means that's a kind of 44 is actually first element, but actually it's not the way to we can stick to output. Actually, if you we supposed to start get first 15 first. Okay, that's it. Not a very proper example. And in Java, okay, let's say Java is also push. There is no put. Okay, that's also fine. There is a, I think there should be pop, right? Okay, good. Pop is empty. Then you just need to avoid, but is not empty. Then you needed to get access top first. You needed to access. What's the increasing the index, right? So the operation is, for example, let's say now push. If you remember, the push is, for example, you put this 44 is now 0, right? Because at the first is what's the, if you remember, yeah, -1. Top is -1. So first one 44 is at the moment the top is 0, 10 is 1, 64 is 2, 120 is 3, 15 is 4. So now you need to get access the I mean pop, right? There should be pop operation. Let's say, do you any pop operation here? No, it's not we should supposed to access. There is no, I think there is wish. Let's say if I'm trying to access one operation here is pop, then what will be output? They will be output 50s, not 44, right? Yeah, so that's another example. Let me say this example. There's any kind of push and pull together. Any push and pull? No. There should be no. Okay, fine. But we can change. We can change the implementation. So that's very interesting. For example, you can push 14s. Then after that, you can pop. Then they will be pop out the 14s. Right. Okay. So that's the example step. First stop. All right. Second one, as I said, there's a two important operation, push and pop. You have to remember. Stacks can be implemented array. As I said, it's a static linked list pointer. Its pointer also is the same, array, right? And the structure. Structure is, do you remember structure? In the C++, they learned what does mean structure. Kind of object, right? Kind of represent many parameter types together. It's kind of composition of the data structure. All right. Now, there is a many references. I also give them as well. If you're interested, just open. Yeah, there is also GitHub. I have a GitHub for the. Oh, right. I think I have to choose maybe. All right. So first big example. I think there should be example. We did structure by that should be, yeah. That's using the structure to create. This is the first example. Second example is using second also structure. Third one is actually linked list. This one is yeah. Actually, this is structure, but first one is I think array. Yeah, they're using the array. First one is a static array. Second one is All right. So let me explain this one. Pop, push, pop. I think there should be has push to all the element. They that's initialization. 1, 2, 3, 4, 5, 6 element. They will be push it. Then trying to do the each operation. For example, pop. So what we'll be doing pop actually, if you added this one, they will be pop is 4 first, then 5, then 3, then 2, right? So that's kind of example. Last one, I'd like to introduce the last one, structure. There's a value. This is two, I mean, actually using the linked list operation. I mean, this one we will be explained tomorrow. It is being called double link list. I think this is a single link list, the first one, because they only has one pointer. This is 2 pointer because they have double link list. We can use double link list to create the, no problem, create the structures. Those can be useful. Okay, let's move to the queue, right? Queue is another kind of special data structure compared to stake. Queue have first in, first out. First in, first out. Actually, they have a who's come first, the serve first. So it means they have a two entry point. First one is you can enter from the enter from the one side, output from the another side. So it is a very important example that usually we will be use queue to use some kind of ordering operation. For example, if somebody who come first, the serve first, then it should be fine. For example, you can handle by order. But a stick is whose insert last one, they serve first. So wondering what kind of application used in the stake and queue. That should be very interesting example would be, you should be asked, usually stake is, for example, what kind of operation? Let's say, for example, if you remember, you can type it any word operation, typing operation, you write the sentence in the any editor, you will be frequently do Control Z to come back to previous operation, Control Z to come back to previous operation, Control Y to repeat the previous operation, come back to the previous one. So that's operation actually used the stake, right? And then Q is actually trying to do it as a order, some operation, then should be useful. That's very important. The term being called the being called FIFO, FIFO. That's LAFO, right? The first in, first out. Okay. So there is a two operation. In Q is insert data, DQ is output data. There is also another peak. There's as is full. There's a kind of extension operation, but it's very fundamental operation in the queue. Let's see what's the queue. I mean, as I said, this is kind of two entry point. I mean, you can insert from the one side, output from the another side. Time complexity, I forget to mention the time complexity of stake. I think there should be mentioned time complexity because it's important to algorithm the structure. All right. Okay. They didn't mention, but I can tell you that those are the time complexity, last in, first out. Last in, first out. If you do any kind of insert operation. For example, for certain position, they will be n time complexity, But you also find position they will be spend the linear time. Then also they will be put it again. So it is, yeah, let's say linear time complexity for doing insert. But for if you're trying to just finding the last one and then just inserting operation without concerning the index or without concerning the any position, they will be fixed time. And the queues also same. If you without concerning the position, that's insert and delete is fixed time, because they just need to one times. You just get this without any time. I mean, that's the reason insert delete is fixed time, right? Search is in time. They will have to go one loop. Space complexity, there is no extra space will be spent, so that's n time complexity. So yeah, you can, if you're interested. So that's a pseudocode. There is two important DQ, InQ and DQ. There is also should be give the another. Maybe I can. Yeah, there is a we can use. By the way, we can use standard library to create the queue. Then also we can use the linked list to create. There is no problem. So as long as you, for example, that way in the GitHub, let's say in the GitHub, actually we used it using the very fundamental data structure linked list to create it, but actually they have a standard library STL to create it. For example, they have a in the C++ Q library, so you can directly get from the use it. For example, you just initialize it, just push it, then pop it. And then this is a queue, so that's the reason they will be actually, for example, push first, they will be get first. So for example, this is a 10, 20, 30, but size 10, after that, you will be get 10 because this insert first. But if you're using stake, instead of queue to stake, that should be different. I mean, they will be pop first 30. That's a very distinguished difference. Why you? That's the reason we need to put together stake and queue together. Why we needed to learn. So as long as you understand this difference, if you understand one, understand second one is no too difficult. All right. So at first, at last, delayed. I mean, you can yeah, actually those kind of operation. You can imagine that. As I said, queues efficient for insert and delete. Yeah, because the fixed time complexity. Search is linear time, also it's better than cogetic time. That's it. So I think it's end of the lesson. Let me just do very quick conclusion. It's very we have left 10 minutes time. So if you have any question after that, you can ask. So we had we start learning to perspective how to measure any algorithm, right? So that's when we talked about the bigger concept. You should understand the fixed time, which is that O1, linear time, ON, login time, O login. It's actually two-based login, and then also some N login is very frequently used as some data algorithm measurements. So that's also we added together. So then that's very important to imagine in your mind those number, what's login is look like, what's the n, what's the n log n, what's the n square. So after that, you will be understand in between the some applications, some example, what's the difference. You also understand that we in the finally in the middle of the semester we will be explain the sort and the search, but right now we just give the example. You don't necessarily, if you too confusing currently for search and sort, no problem. We will be learn later, but that's kind of give you a little bit hint. Try to understand the example. Then also before then we beginning to analyze certain one true data structure, stack and the queue. But before that, in order to understand stack and the queue, we will be give the short description of the array and dynamic arrays as well. No problem. It's the same things. Only difference is the size. So actually, the arrays, they will be positioned. They will be located in memory sequential order. So that's the reason we can able to access by index. That's the reason that we can find any element just fixed time. But the late insert, they will be spent the collected time. So that's the problem. So this we try to use array to do such kind of operation. But stick and queue delete, and if you remember, queue operation, stick, insert, and delete is better than array, right? Interesting. So if you're trying to delete and insert, if you queue and stick is better, you use it, stick and queue. But they only have a two operation, very pop and push. Queues double side of the data structures, and the stick is one side of the data structures. They have only one checkpoint, so they will be insert first, then output in the same entry point. So that's a very limited operation. You have to understand that if you imagine your mind that, okay, they have only one checkpoint, that's a stick. It's a very short description. I mean, very famous word. LIFO is stick. FIFO's queue. What's the FIFO? It means first in, first out. What's LIFO's? Last in, first out. That's explaining of the short word abbreviation. All right. So I hope that should be end of the lesson. I hope you have a question. Then I can able to answer. No. Any question, please?
No questions right now.
Can you, what do you mean? What's your question? Repeat again.
I said no question. I meant like I don't have a question. That's just what I want to clarify.
Okay, maybe you have a question later on after that. Yeah, review some materials, right? Actually, in the Teams, we have a video, right? But you can find those material if you join another group. I leave them group code, right? So for example, somewhere, I think here's where it is. Yeah, actually, that's if you join that group, you can able to see those posts, the files, so you can able to see each week of the content. So the previous one, for example, what kind of reference, what's this mean, simple topic, what else? Sometimes even they had lecture note, maybe video as well, video lecture. So I think you can combination together. That would be better. All right, I think that will be. I give them, if you try to use other reference, other materials, you can easily find previous our group, right? Okay. If you without question, now it's time to leave for lecture. About lab, we will be start doing the lab this week. I mean, right now, immediately. I think you already create account. You get the email. You get this login and password, right? You can try to use it. Try to complete it in the. I will be give a each task. What to say? Till checkpoint. I mean, you needed to complete the. Before the checkpoint, we can. Otherwise, otherwise you will be get default 75 point. Okay. So yeah, you just need to hurry on. Hurry. Sorry. So if you without question, you can leave now. You get the account, you try to get your task, then yeah, try to complete it, and then yeah, we will be have another time. If you have any question, then yeah, we can ask. Any question, guys? Hello. If you without question, you can leave now.
Goodbye.
Excuse me, can I ask?
Yes.
Do we have the link for the judge?
Same as before. I mean, I will be give a post how to get access later on. Okay.
Okay. Okay. Thank you.
Sir, what is the deadline for the lab one?
I mean, there is as long as you know, it's kind of short week, right? We have a 6 week. As I said, the each lab you can continue to do it till second week. We have a second checkpoint. At that time, I will be gather the data from the e-judge, right? So in the actually, let me just open it, my syllabus. So what's you can you can reference the syllabus, okay? So what is actually we doing is we have a the this is first week. We have a second, and when we doing the third week, actually, and each week we have a 3 lab, right? So it's there has a 6 lab. So it means 6 lab you will be uploaded till third week, and then third week in the Tuesday I will be download from the e-judge the 6 lab. Then I will be get average point. Then same time you can able to upgrade if you try to upgrade. I mean, if you're not satisfied, but that means you need to can have you should first upload first, then you can come to defend. So if you're not satisfied 75 point, then you can come to university to you know, defend your work. That's the plan. Okay, understandable? So it means when we third week, we have to complete third week Tuesday. Okay, third week Tuesday, you have to complete six lab. Then we have a 1 checkpoint, and then I will be get the average point, put this midterm 1. All right, so that's series midterm 75 for midterm. That means, I mean, if you already do the lab, this full point, then you will be get 75 without defending.
Okay.
if you want to defend, this is maybe you can get another 25% of the work. Understandable?
Yeah,
I mean,
it's clear, sir.
I forget. I mean, there's okay. I forget to share my screen. What it means is, I mean, each week we have 3 lab, and then this is one, and second week we have a 6 lab is supposed to be accomplished. Then you need to upload the e-judge. Then you have in the third week, I will be get the result from e-judge, put your mark average point for get the midterm 30%. All right. Then it's the 5th week. We have another three. I mean, there is at last 5. I mean, 5 and 6. Let's say 5. Okay. Then get another checkpoint. Any question? That's understandable. So basically, when we third week, you need to pass your lab. I mean, deadline is till third week. We have to complete 6 lab. All right. Then you will be without defend get 75 point. Understandable? Any question?
Yeah, it's clear, sir. Thank you.
All right. So goodbye. Today is enough. If you have any question, we can discuss. Just get familiar with those results, those materials, as long as your task. So then probably have a question. All right. Okay. Please leave. Otherwise, the record is keep doing that. Should be annoying. No question? If you have no question, I will be close. Goodbye.
Ассаламу практика бола ма?
Қалай?
Практика бола ма бүгін?
Практика неге болмайды? Практика басталды ғой. Мен саған тәсіпті бердік қой. Саған аккаунтыңды бердік. Енді сол жерде description бар. Ижажын білесің. Тапсырмаңды істейсің. Қазір бәлкім сұрақ болса, қазір бола қоймайтын шығар деп ойлаймын. Өйткені сен лекцияны көресің, сосын практиканы бастап істей басасың. Бәлкім келесі жылдан бастап сұрағың болатын шығар. Сол кезде сұра. Немесе сұрағың жоқ болса, ижажыға істеп қоя бер.
Ол ағай аккаунт қай жерде тұр? То есть кіретін вход қай жерге кіруге керек?
Дей, мына бала не? Сен оқуды білесің. Мынаны қарасаңшы, елдің бәрі сол жерден қарап алып жатыр ғой. Мен сіздерге, сіз өз нешінші курстың студентсіз? Данияр ма?
Тоже логин, паролімді білемін ғой.
Иә.
Қай
Ссылкасы
жерге
ма?
кіремін деймін да?
Ижажын бұрын істетіп бердің? Мен біраздан кейін мен сол ссылканы жіберейін, жарайды. Жазып қояйын,
Жақсы. Ссылканы таба алмайтын сол.
Жарайды, жаз.
Аха.
Сау болыңдар. Сұрау жоқ болса мен өшірдім.